This is video 24 on MicroPython and the third example on LVGL 9 on a Raspberry Pi Pico. In this video, we review 3 widgets in LVGL 9. Each has a list selection in common. First, we look at a simple list. Then we look at a roller widget. And finally, our third example is a drop-down widget. In this video, I will also demonstrate a MessageBox, and I will discuss styles and parts. For this effort, I continue to use the Pico MicroPython display baseboard with the Pico-W USB board and an Ili9341 display with touch. The GitHub site contains the firmware for both the Pico and the Pico-W and the code examples. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. All of the code examples use an updated display driver. This is the display and touch setup definitions pushed into a file on the Pico. Last time I added an ability to hard reset the Thony because of display connection, and Thony does not respond properly to a soft reset. Now, if we press the red reset button, a message box is displayed, allowing us to choose a hard reset. Or, to avoid accidental resets, one can click the upper right X to cancel the reset. Otherwise, you can use the REPL in the shell of Thony to enter h.reset, and that will do a hard reset. Finally, if you forget these other methods, you can always just yank the USB cable and reconnect it. Our first example is a simple list widget, which contains text and buttons. Let's run the code. I'll click the green run icon, which starts the program, and it follows the REPL. And that is because I've coded all these examples and commented out the timer loop at the bottom so that we can just interact with the UI and its events. All right, let's give it a try. So all the text items become headers within the list and are not clickable. All the buttons are list items. So I can click on the open button and it's selected and it's displayed in the Thony, as well as updated the label box. I can click close. It does likewise. I can click new. All right, now that we can see how the list item works, let's look at how it's coded. So in our code, we first begin by defining a widget for the label output. And so currently you can see the label is this blue box that contains the word new. Next, we define a style for the list. And this is what it's giving it: the black background and the white text color for the fonts inside the list. We define a callback, which I'll cover in a minute. Now we define the list. And we give it a position, a size, and then we add the style up above. The list is defined by, we explained earlier, adding text for the headers, and then adding a button method for each of the buttons. When you define an add button, you need to provide a constant for the icon. In this case, I want the symbol file, and then the text for what you want as the list item. In this case, it's new. Okay, so when we click on a button which is looking for event clicks, and it will call this callback because I defined it in the add event callback. And remember, we always pass none in the data pointer. So in our event, first we get this object we know to be a list item. And so we can use its get button text to get the text of the object that was clicked. We then simply print it or update the label with that. So this is much simpler than a regular button because the list object has a get button text method. All right, now that we understand how the code works, and how easy it is to create a simple list widget, the question comes to mind is, where did I get these symbol constants? And the symbol constants I get from the documentation, or I can use a simple trick of the MicroPython repo system to find out what symbols are in the firmware. So let's come down to our shell, and we're going to define s equals lv.symbol. And we could hit enter. And now we have this temporary variable s. And so we can use this feature of the MicroPython repo to type s dot, and we get this linting capability where it shows us available values that we can choose from. And you can see here all the icons that are in the firmware, and there's over 60 of them. We can simply use these in our program now that we know their proper names. Okay, let's press reset and load the next example. So when I press reset, I get the message box that we talked about, and I can either press X to clear it, or I'll press it again, or I can press reset to reset the display, well, to reset the Pico. Okay, I've reset the Pico. I'll select the next example, which is test_roller_display. I'll stop and run that example. The code defines a list-like widget called a roller, which contains a list. In this case, I've populated the list with the values 1 through 10. And we can take our pointer object and drag it across the roller and choose a different value. So here I've chosen 6. Okay, so let's take a look at how the code works. So we're going to scroll down, and oh, you may have noticed that I also added a spinner widget that runs at the beginning of the code. In fact, let's see that again. The spinner is going to run in the middle of the screen. So let's reset the program and rerun it. And it's going to be fairly quick. You'll see a circle object that is alternates with white and blue, and that runs very briefly. And that's because it starts running at this point in the code on line 34. And then when we get down to line 90, it's going to spin and fade out after 1 second. So it's just a neat little feature. All right, so let's look at our program. I've defined a label for the selected roller value, and right now you can see it contains the value 5. And it has a lot of definitions here for the styles that we've not seen before. And I'll come back and discuss those in a little bit. It has a callback for the roller. Define styles for the roller. So I've defined this particular style, which we'll come back to in a minute. And now we define the roller widget. The roller is going to be positioned in the center. It's going to add this style using this part main, which I'll cover in a second. It's going to show visibly 4 numbers. If we remember that computers like to index from 0, so this is really the 5th item. So 1, 2, 3, 4, 5. So it's showing 5 items. So let's look briefly at styles, particularly for a roller. The roller widget is a list object with certain states and 2 LVGL parts, a LV part main and an LV part selected. Each part can have a unique style. As we stated earlier, styles affect the properties of a widget, such as location, size, and color, and so makes a screen more appealing. I found the parts of a roller widget by looking at the online LVGL documentation. This page is showing the part constants. There is no MicroPython specific documentation as LVGL is coded in the C language. Fortunately for us, the MicroPython library is just a binding of the C code, and so the constant LV_part_main becomes the constant LV.part.main in MicroPython. Go back to the code and let's look at line 70. On line 70, you can see that I've added a style to our roller definition. And this style is this part up here. And we can tell that this applies to the overall roller because we've told it to apply this to lv.part.main. So all of the list items, except for the selected area, will be impacted by this style. Just below that, on line 72, you can see that I defined another style. This time, I've told it to apply this style, which is the color, to lv.part.selected. So this color change is only applied to the selected area of the roller. Likewise, on line 73, I apply another style, which is to change the text color to red. But again, it's only in the lv.part.selected area of the widget that I make this change. As you can see, all other items are using the default row style that we did at the beginning. In a similar manner to how we located the symbols, we can dynamically make changes to our widget. So I'm going to copy this style, paste it, and now I'm going to go to the color, and one of the colors is yellow. And I can change the roller widget dynamically through the shell. And you can see on the display it's been changed to yellow. I can change it to a different color. And it's changed to orange. I can change it back. We can manipulate any variable in our program or add variables dynamically in the Thony shell to our running program. And we can see the changes instantly in the display. So that's a nice feature of MicroPython. Okay, let's press reset and load the next example. I'll press the green run icon to start the program. The drop-down code example consists of two objects. The object on the left is the drop-down, and the object on the right is the label. I can click on this object in the drop-down, and it produces a list. I can then select an item, and that item is displayed in the drop-down object, as well as it's updated on the Thony, and it's updated in the value in the label. When we look at the documentation for dropdown in the LVGL documentation, we see that dropdown consists of two objects within the widget, a button object and a list object. Each of these have parts to which we can apply styles. As we walk through the code, we've defined a label output as we have in the other examples, and this will hold the selected value. Next, we defined two styles. We define a style for the drop-down button, and we define a style for the drop-downs list. And notice that these are different. So the drop-down button has the background color of black and a text color of white, which you can see on the screen. If we go to the list by clicking on the drop-down, we can see that we've defined the list such that the text color is yellow, and it's yellow on my screen. You can barely see that, but it's yellow here as well. And the background is black. It's a different color and style for the drop-down list than what we have for the button. Finally, I also defined a style for the selection. So let's click on Raspberry, and you can see when I click on it, it changes to cyan. Let me click on it again. And now I've selected it, and it's become white in the combo box. So each of the parts, I've defined a style. So next we write the code for the callback, and we configure the drop-down. So let's look at the drop-down. The drop-down, we set a size, and we apply the style. And that style is that white text for the button. And we can see that we're using part main as our documentation told us that we could. Now, remember, the drop-down list is different. When we talk about the part main, we're talking about the part main within the list object. So here, we're getting the list, and the way that's done is from the drop-down object, we say get list, and now we can apply a style to this list area. And as you recall, we defined this list style as having a yellow color, and you can just barely see yellow in the display right now. Also, I added styling to the scroll bar, so I made it slightly bigger. So you see that I made it a wider scroll bar so that it's more visible to us as we move through the list. And so I used the part lv.part.scrollbar in order to affect a change to that style of that part. Finally, I can apply a style to the part that is selected. So again, here, let's click on orange, and when I do, you see that the yellow changes to blue. And that's because this style right here says to change, well, it changes to cyan. It says to change the text color of the item that I have selected. Next, I have the statement to load the DD, the drop-down object DD with its values. So it's just a list of values. And finally, I am aligning this within the screen object to a position 10, 20, and then I define the event. I'm sending all events to this callback. So when we look at the callback code, we see that the first thing it does is it gets, we have a new statement that I haven't shown before, which is called code, and it's defined as event.get_code. And this is going to get the value of the event, and you can see how it's used right here. If the code value is equal to LV event.value changed, then I want to do something with that. So there may be a lot of other events occurring in the background, but I'm ignoring all those except for event value changes. Also, I get the DD object using a familiar get target object. So now I have the object, I have the actual drop down, and here we have a method called get_selected string, which requires a buffer. And so I've created this buffer called option, which is 10 characters wide. And we've updated that buffer with the value that was selected. Okay, now that I have that value in option, I'm going to print it to the screen, as you can see down below, as well as I'm going to update the label. but here I wanted to make sure I stripped off any extraneous spaces. So that's it for the examples. In summary, we reviewed 3 examples: a simple list, a roller widget that contains a list, a drop-down example which displays an optional list. We discussed styles, and in particular how to change the styles for a specific part of a widget. And we explained the use of MessageBox to handle our hardware resets. I hope this helps your coding, and thank you for listening.